Hello, and I'm John Rutger, and I had problem 13 from section 2.2. In this problem we are given a third order homogeneous linear equation and three linearly independent solutions are given. All the problem is asking us is to find a particular solution satisfying the given initial conditions, which I wrote right here. Right away I'm going to put this into our solution form, which would be y is equal to, which would be our y1, so I'm going to use a, b, and c as my constants, so this will be a e to the x plus b e to the negative x plus c e to the negative 2x. Now we're going to want to find the derivative. Sometimes people do it outside of doing it in the equation. Here, just to make it simpler, I'm just going to go through. We know the derivative of e to the x is e to the x, so our derivative of y will be a times e to the x plus, well, we know that the derivative of e to the negative x will actually be negative e to the negative x, since we're going to have to take that constant of negative 1 times our x and bring that down. So this is actually going to be minus b e to the negative x. And for our second one, we're going to have to do that same thing, but this is a negative 2. So now we're going to have negative 2c e to the negative 2x. Now let's do the second derivative of this. This is going to be a e to the x again. Now we're going to change this back to a plus b e to the negative x, and this one will be a negative 2 again times, that'll be just plus 4 e to the negative x, or negative 4 or plus 4 c e to the negative 2x. Now we're going to have to use these three equations and make it so that these initial conditions are true. So we'll go through and put 0 in for x. So in our first equation, putting 0 in, all we're left with is a. This will be, since that was 1, we'll have, this will be another 1, so because e to the 0, that's 1, so we'll have a plus b plus c, and this is going to equal 1. For our next one, again, e to the 0 is 1, I should state that, so we're going to get rid of that. Again, e to the 0, and e to the 0. So we're left with a minus b minus 2c, and that equals 2. Again, we're going to get rid of our e to the x's because those turn to 1. This one's going to equal 0. We're left with a plus b plus 4c. Right away I jump in by taking our a plus b and make that equal to 1 minus c, and just take the c over. So our a plus b equals 1 minus c, and there's an a plus b right here in this equation. So I'm going to put that in. I'm going to put 1 minus c in for a plus b, so we're going to get 1 minus c plus 4c, and that's going to equal 0. Taking this down, we're going to have 1 plus 3c equals, and we'll subtract this 1, so we'll have negative 1, divided by the 3, cancel that out, divide by 3. We're going to have, what we're going to have left is c is equal to negative 1/3. Okay, so now knowing that, I'm going to pick the next easiest way to find one of the constants, and that's right here. We have a negative b and a positive b, and those will cancel out, so we'll be left with 2a plus 2c equals 2. Adding these two equations together, that's what we come up with. In the end, we're going to be left with a plus c equals 1. and we know now our c, which is negative 1/3. So a minus 1/3 equals 1. Add that over, we're going to have a equals 4/3. So now that we have our a and c, we can put that into the first equation, which is just a plus b plus c equals 1. Already we can see that a plus c equals 1. But going through it, we'll see that now that b is equal to 0 from that. And since our b is equal to 0, that will cancel out our y2, which is e to the negative x. So all we're going to see in the final equation is our e to the x and our e to the negative 2x. So writing out the final equation, the solution that we need, we were asked of y of x is equal to 4/3 e to the x minus 1/3 e to the negative 2x. And that's our answer. Thank you for watching.